Good afternoon to all. Today our third lecture. Before starting today's lecture, within 1 minute, revise all the points covered. Okay. So our first point is mechanical measurement. Why mechanical measurement is required and what is this content. Then definition of measurement. Then definition of standard. Then why measurement. So measurement is required for to improve the quality of product, to improve the efficiency of production, and to maintain the proper operation. Then why instrumentation is required in any industry. So to acquire data or information about parameter in terms of putting the numerical value to the physical quantities and making measurements otherwise inaccessible. Okay. So basic requirement of measurement system or measuring system. There are two basic requirement of measurement system. First one is the standard used for compression must be accurately defined and commonly accepted. And second one is the procedure employed for the measurement and the apparatus used for compression must be accepted and provable. Then next point is significance of measurement. In that, when you measure any unknown quantities, you have to take first input, then select one process, and then output is form of digital or in numerical value. Then fundamental methods of measurement. In that, two fundamental methods is there: direct compression and indirect compression. Indirect compression method to compare direct compression method is direct measurement method. In this method, measurement is made directly by the comparing the unknown magnitude with a standard, and the result is expressed by a number. Then indirect measurement or indirect compression. In that, uh, the chain of devices which is together called as measuring system is employed. Means indirect compression method, for example, taking dimension or taking length of unknown quantity of bar is a direct compression method or direct measurement system. And indirect measurement system or indirect compression system is that number of direct compression instruments are combined together, means chain of devices which is together called as measuring system is employed. For example, um, Bourdon pressure gauge. Okay. Then primary, secondary, and tertiary measurement system. Okay. In primary measurement system is that easily made by direct compression method or observation. For example, matching two colors in finding the temperature of red hot object. Secondary, indirect indirect measurement involvement translation are called as secondary measurement. The conversion of pressure into displacement. For example, bellow. See the diagram of bellow. Pressure P2, displacement, and pressure P1. Displacement is changed. Then tertiary measurement. In tertiary measurement, indirect measurement involving two conversions are called as tertiary measurement. Means combination of two indirect secondary measurement is the output of tertiary measurement. The measurement of speed of a rotating shaft by means of electric tachometer is the example of the tertiary measurement. See, this is the diagram of Bourdon pressure tube. Then our syllabus first point is generalized measurement system. Okay. Let's see the block diagram of generalized measurement system. Physical quantity to be measured, primary sensing element, variable conversion element, variable manipulation element, data transmission element, data processing element, data presenting element, and observer. These are the block diagram of generalized measurement system. Here is the description of pointwise of generalized measurement system. First one is a primary sensing element. The primary sensing element receives signals of the physical quantity to be measured as an input. Then variable conversion element. These are used to convert the output of the primary sensing element to a more suitable form. It is used only if necessary. Then Third block is a variable manipulation element. In that, variable manipulation element manipulate and amplifies the output of variable conversion element. Okay. Then fourth one is a data processing element. When receiving the all three blocks data, these are processed. It processes the data signal received from the variable manipulation element and produce suitable output. This output transfer to the data transmission system. In data transmission system is simply used for transmitting the data from one element to the another. Okay. Then last one is the data presenting element. Here data presenting element displays our final output or outcome with the help of numerical value or digital value in LED display. Okay. Then next point is the instrument characteristics. Which is whenever instruments are used in industry or mechanical or any industry, these are the basic two characteristics in their statics characteristics and dynamic characteristics. So what is mean by static characteristics? So normally static characteristics of measurement of any instrument, measuring instrument, those are must be considered when the system or equipment is used to measure a condition not varying with the respect to the time. Okay. These are the static characteristics. And dynamic characteristics means this is system quantities to be measured very rapidly with the time, means dimension change with respect to the time. Also the basic concept and definition of this point. First is readability. Readability means readability. These terms indicate the closeness with which the scale of the instrument may be read. For example, instrument with 30 centimeter scale has a higher readability than that of 50 centimeter scale. Okay, means you have to take 50 centimeter scale. This is readability is a 50 centimeter, and 30 centimeter scale is a readability means extreme stage is a 30 centimeter. Then least count means minimum count. Any instrument, any equipment count a minimum value that is called as least count. It is the smallest difference between two indications that can be detected on the instrument scale. Okay. Then range. The next point is next definition is a range. Range is defined as the lowest value to the highest value, means difference between lowest and highest value. Calculated value of this instrument. It represents the highest possible value that can be measured by the instrument. Then next with the error. Error means the difference between the actual reading and standard reading. Next is the calibration. Whenever instruments or equipments are used in industry, they are regularly maintain his calibration because of accuracy and maintain the continuous reading. So the procedure adapted to prove the ability of measuring system to measure reliability is called as calibration. So means whenever instruments or measuring instruments are used in industry, month wise, quarter wise, half quarterly, semester wise or year wise, they are regularly maintained to calibrate for better uh, measurement. Okay. Then hysteresis. It is an instrument said to exhibit hysteresis when there is a difference in reading depending upon the whether the value of measured quantity is approached to the higher value to the lower value. Okay. Then sensitivity. Sensitivity concept is related to the whereas used to the pointer means surface finish. You have to measure surface finish. You have to use a dial gauge. Dial gauge are used to measure surface finish. So here at the touching point, rough plate, surface plate, and dial gauge pointer. At that time of touch pointer to the surface plate, this pointer is use again and again, this wear and tear is there. There are sensitivity is decreases. Otherwise, it is the ratio of linear movement of the pointer on the instrument to the change in the measured variable causing the motion, or in the ratio of magnitude of output quantity, means response to the magnitude of input quantity. Then next definition is a resolution. So resolution means is the smallest increment of input signal that a measuring system is capable of displaying. Then next definition is threshold. Threshold is measure when the input is varied from zero, while the resolution is measured when the input is varied from arbitrary non-zero value. Okay. Then repeatability. Repeatability is the ability of measuring system to reproduce output readings when the same input is applied to the consequently under the same condition and in the same direction. Then reproducibility. Reproducibility is the degree of closeness with which the same value of variable may be measured at a different times. The next definition is linearity. Okay. So our next syllabus point is sensor and transducer. Sensor and transducer are different two devices. Means sensor for sensing element and transducer is for sensing and associated circularity. Okay. So uh, see the definition of sensor. It is a device that detect a change in physical stimulus and turn into a signal which can be measured or recorded. This is called as sensor. For example, thermistor. Yeah, next point is thermistor is a temperature measurement device. Yeah, this is our next point. See in details. Next definition is what is meant by transducer. So transducer is a device that converts energy in one form into another form. So the majority either converts electrical energy to mechanical displacement or converts some non-electrical physical quantity such as temperature, sound or light to an electrical signal. For example, thermistor with associated circuit convert heat to electricity. Okay. See the comparison between sensor and transducer. So sensor for a sensing element itself and transducer for the sensing element plus any associated circularity. All transducers would thus contain a sensor and most, not all, sensors would also be transducers. Okay. Next point is the classification of transducers. I request all of you to draw this block diagram within 2 minutes. I request all of you to draw this block diagram within 2 minutes. The classification of transistors first is on the basis of principal use in that capacitive, inductive, and resistives. Okay. Then active or passive. Then primary or secondary. Then analog transistor or digital transistor. Then transistors or inverse transistors. Okay. So transistors may be classified according to their application, method of energy conversion, nature of output signal, and so on. These are the classification of transistors. Okay. See the basic concept or introduction of transistor is the efficiency is equal to I output divided by I input. Means I output means the information delivered by unit divided by information received by unit. Okay. So transducer is the first stage element of the measurement system. Transducer is the first stage element in measurement system. It detect and transfer the sensed signal into more useful form. Okay. So ट्रांसड्यूसर क्या करता है ओनली फर्स्ट स्टेज पे डिटेक्ट करता है सेंस करता है एंड दिस डिटेक्टेड वैल्यू ट्रांसफर टू द next form. Okay. So transfer efficiency means it is the ratio of output information delivered by the pickup sensor to the information received by the pickup. So the efficiency of transducer means I output divided by I input. Then how transducer sense or the sensing process. First one is input energy means signal. The transducer senses this input energy or signal and transfer to another signal or output energy for further processing. Then function of transducer. Okay. See the diagram. Transducer measurement, excitation, and so function of transducer to sense the presence, magnitude, change in and frequency of some measurement. And this sensible value or inputs transfer or provide an electric output that when appropriately proceed and applied to readout devices means display devices gives accurate quantitative data about the measurement. Okay. So transducer क्या करता है first we sense the input signal also magnitude or any frequency they are senses and transfer or proceed to the readable devices or output devices. So measurement refers to the quantity, property or condition which the transducer translate to an electrical signals. Okay. Then see the classification of transducer in detail. So classified according to their application based of primary. application based the primary on physical quantity, property, or condition that is measured. First one is the passive transducer. It requires external power. Output is a measure of some variation, such resistance that capacitance. For example, condenser, microphone. Okay. Second one is a self-generating transistor. Is that not they not require external power and they produce analog voltage or current when simulated by some physical form of energy. For example, thermocouple. Then selection criteria or selection parameter of transducer. First one is the operating range, second sensitivity, third frequency response and resonant frequency. Fourth one is the environmental capability. Fifth one, minimum sensitivity measurement. Then accuracy. Then uses and ruggedness. Then electrical parameters. See the classification of major classification of transistors: temperature transducer, resistive position transducer, capacitive transducers, inductive transducer, strain gauges, LVDT, linear variable differential transducers, and photoelectric transducers. Okay. Then see the details of classification of transducers in that active or passive transducers. Okay. So active transducers, for example, piezoelectric transducers. Then next slide, we have to see the details of what is meant by piezoelectric transducer with the help of diagram. Uh, Active transistor is also known as a self-generating type transistors, develop their own voltage or current. Energy required for the production of output signal is obtained by quantity being measured. For example, electronic and piezoelectric transistors. Then passive transistors. In that passive transistor is an extremely power transistor. Means in active transistor they not require external energy or external power. So in passive transistor require externally power transistors derive the power for energy conversion from an external power sources. Okay. For example, bonded electrical resistance strain gauges. So strain gauges is also seen in details with next slides. Detector transducers or primary transistors. Here the sensing element may serve to transduce the sense input and convert into a more convenient forms. Okay. For example, ordinary dial indicator means spindle act as a detector, and load cell detect for the force load applied and gives a output in the form of deflected. Means this transducer works on the linearity or the for example, you have to measure the RPM means revolution per minute with the help of tachometer. Then secondary transducers. In secondary transducer, for example, strain gauges, load cell. So it detects the force and gives a output of the form of deflection. This deflection may further be converted into an electric output by strain gauges, means mounted on the load cells. Okay. See, see the Bourdon pressure gauge. Another type of the transducers. The tube act as a detecting transducing elements. Means this circulating tube in that act as a detecting transducing element for a transducer, and this linkage act as a this linkage gear linkage uh, and gear linkage uh, attached to the this pointer. This act as a secondary transducers. Okay. So primary detector transducer classifies again based on the number of operations performed. Class 1, first stage element used as a detector only. Class 2, first stage element used as a detector as well as transducer. And class 3, first stage element used as a detector and two transducers. Okay. Then mechanical transducer is a burn-down pressure tube uses a mechanical transducer. In quantity include force, pressure, displacement, flow, temperature, etc. So the mechanical transducers are used to measure the force, pressure, displacement, flow, and temperature. The mechanical transducers commonly used to convert the applied force into displacement and elastic members. Okay. Also, they may be suited to either direct tension, compression, bending, or torsion. In that spiral springs, torsion bars, proving rings, pressure sensitive element. These are the content of mechanical transducers. So most pressure measuring device use as elastic member to sense the pressure. These elastic members convert pressure into displacement and can be of the following types. In that, Bourdon tubes, diaphragms, and payload. So Bourdon here, see the details of the Bourdon tube. Okay. This is a Bourdon tube pressure gauge. See the details of Bourdon tube pressure gauge. Here is the diagram of Bourdon tube pressure gauge. Here pressure input. Here I apply the air pressure and this air goes to the here. This is hollow evacuated tube. In there, this tube connected to the gear and linkage to this pointer. When you apply pressure here, this tube deflect slightly and this rack and pinion arrangement attached to this pointer and pointer move left side and right side and display the readings in here magnified tube. Okay, so see the how work the Bourdon pressure gauge. So input pressure in Bourdon tube. Okay, so that is primary sensing element means transducer. Then second displacement here when applying pressure this tube get expand means displacement means mechanical linkage and gearing. Mechanical linkage here, mechanical linkage and gearing. Then next pointer or scale. Here applying pressure. Here applying pressure, this linkage get converted into readable readings. Then term sinks range. This means pointer sensor. Okay. These are the different transducers. See only diagrams. There are no description is required. So flat diaphragms, coagulated diaphragms, and metallic capsule. Here, coagulated diaphragm to applying pressure, then check the displacement of the spring. Also same here applying pressure here P1 and P2 and see the change in displacement and calculate the reading. Same working here, applying pressure here to here and change the displacement with the help of reading. Then electric transducer element. Okay. Uh, Here is a mechanical transducing element. Next point is the electrical transducer element. So most measuring devices have electric element as secondary transducers that convert the displacement of a primary sensor into the electric current or resistance or voltage. And the transducers may be resistive, inductive, or capacitive type. So, uh, if any lacunas remaining in mechanical transducers, some changes in these transducers and used as a electric transducer. So, advantages related to the mechanical transducers uh, is electrical transducer is very small size and compact. Then functional and internal effects are reduced. Then remove recording and control possible. Then amplification and attention of signals may be easily obtained. Then less power consumptions. And then signal output may be easily processed and transmitted. Okay. These are the advantages of electrical transducers over mechanical transducers. Okay. Then resistive transducers. Okay. So the resistive transducer of an electrical conductor varies according to the relation, where capital R is equal to rho L divided by A, means R is the resistivity of the material in ohm centimeter, and L is the length of the conductor in centimeter, and capital A is cross sectional area in centimeter square. So in this method involve design criteria, design criteria for the transducers following some types. Okay. See the diagram only. These are the electrical transducers. So first one is the sliding contact resistive transducers. See the sliding contact resistive transducers. Then potentiometers, angular motion potentiometer. See only diagrams. No description is required. Very small point is there. Only electrical transducer definition and advantage and disadvantage is required. Then variable self inductance, two coil, that single coil with center tap. Then variable mutual inductance, two coil. Then a variable reluctance. See only diagrams. No description is required. Capacitance transducers. These are the electrical transducers. Okay. Piezoelectric transducers and photoelectric transducers. Also photoconductive transducers. These are the example of electrical transducers. Ionization transducers. For example, bulb also is the example of ionization transducers. Electro Electrokinetic transducers. Okay. So within 2 minutes, revise the 2 days covered point. First one is the sensor and transducer. So sensor is a sensing element and transducer is a sensing plus associated circularity. Then classification of transducer in that capacitive, inductive and resistive based upon the principle used. Then active or passive transducers. Then primary or secondary transducer. then analog or digital transducers, then transducers or inverse transducers. Okay. Then what is meant by transducers? Is a transducer is a first stage element of measurement system. It detects only and transforms the sensor signal into more useful form. Then how transducer is a work when uh, sensing process, this input energy or signal senses the transducer and transfer to the output energy or signal to the further process. Then function of transducer to senses the presence, magnitude, change in and frequency of some measurement. Then classification, active transducer, passive transducers. Then parameters, where you selected the different transducers. These parameters are considered. First one is operating range, second is the sensitivity, third is the frequency, response and resonant frequency. Fourth is the environmental capability. Fifth one is the minimum sensitivity measurement. Sixth one is accuracy. Seventh one is the uses and ruggedness. And last one is the electrical parameters. Then where the transducers are used, different transducers means temperature transducers, resistive position transducers, capacitive transducers, inductive transducers, strain gauges, LVDT, photoelectric. See the active and passive transducers. Active means they do not require the external energy or external voltage or input current. Passive, they also externally required energy or input, derive the power of energy conversion from external power source. Okay. These are the active and passive transducers. Then secondary transducer, for example, strain gauge, load cell. Then Bourdon pressure gauge is an example of the secondary transducers. Okay. So in Bourdon pressure gauge is a primary detector. This tube acts as a detecting transducing element as a primary detector transducer and linkage. This mechanical linkage, rack and pinion or gear arrangement attached to the pointer act as a secondary transducer. Okay. So class 1 is the first stage element used as a detector only. Class 2 is the first stage element used as a detector as well as transducer. And class 3 is the first stage element used as a detector and two transducers. Then mechanical transducer example, Bourdon pressure gauge. It include force, pressure, displacement, flow, temperature, etc. These elements of mechanical transducer is a spiral, spring, torsion bars, probing rings, pressure sensing elements. And the major example of this mechanical transducer is the Bourdon tube, diaphragm, and bellows. These are the some diagrams of mechanical transducer: flat diaphragm, regulator diaphragm, and metallic capsules. Then next point is the electrical transducers. Okay, so electrical transducer is very small in size and compact, fractional and internal effect are reduced, remove recording and control possibility. These transducers are have electric element as a secondary transducer that convert the displacement of a primary sensing into electrical current, resistance, or voltage. See the some diagrams of the electrical transducer. First one is the sliding contact resistive transducer, potentiometers, angular motion potentiometers, variable self inductive coil, variable self inductance, two coil, single coil with center tap, two coil mutual inductance transducers, variable reluctance, capacitance transducers, piezoelectric transducers, electrical transducers, photoconductive transducers, ionization transducer, electrokinetic transducer. Okay. So today's talk here. Place roll number division A. Place your roll number and leave the meeting. Division A. Place your roll number and leave the meeting. Division A. Place your roll number and leave the meeting. Division A, place your roll number and leave the meeting immediately. Division B, place your roll number and leave the meeting. Place your roll number and leave the meeting immediately.